When we discuss molecular orbitals, we tend to look at them in one of two ways. We look at them from a standpoint of energy, and we look at kind of a picture of the new molecular orbital. I'll just say this is shape. It's not the best way to say it, but it's good enough for what we need. So let's recall our simple reaction. Atom A with its one electron is going to react with atom B. They're going to share that electron and form a new molecular orbital from the atomic orbitals that come from the individual atoms. And this is actually going to be MOs. We're going to get multiple orbitals. So let's look at this from a standpoint of energy and then a little bit by shape, and then we'll see some specific examples in later videos. So from energy, we're going to have kind of this energy axis. Down here is going to be low energy. Up here is going to be high energy. And let's put atom A over here. And atom A, we're going to represent the atomic orbital of atom A simply by this line. And what do we have in that atomic orbital? Well, we have a single electron. So let's put a single electron, just put a barbed arrow there. And then coming together with atom A is going to be atom B, and this line represents the atomic orbital from atom B, and it has some position on this energy axis, just like the AO from atom A has, and this AO for B also has an electron. And so what happens is, as these two orbitals come closer together, as they approach one another, they're going to meet in the middle here somewhere, and we're going to create new atomic orbitals. So this is kind of the before, and here is the after. And so this side represents the before, and this side on the right represents the before for B, and in the middle we're going to have the after as they come together. So this isn't really a time axis. This is everything's coming together to meet in the middle. And so what are we going to get? Well, we have these two atomic orbitals, and they are going to mix together, and we're going to form two new molecular orbitals. This is an important idea. The number of orbitals that you put in is equal to the number of orbitals that you get out. You can't destroy orbitals. So if we have two separate atomic orbitals, we're going to create two new molecular orbitals. And from an energy standpoint, what happens is these electrons, these atomic orbitals don't exist anymore. So the electrons must go somewhere. So these electrons will fall into the new molecular orbitals. And where they go to the lowest energy orbital possible. And so they end up, both of them will fall down to the lowest orbital possible. And so here's a molecular orbital. We'd say this molecular orbital is filled because it has two electrons in it. That's the most electrons you can put into an orbital. And this one's vacant. So this is a vacant orbital. And this is a filled orbital. And note that this gives us an indication of why we get bonding. These electrons, once you form the new molecular orbitals, the electrons get to fall down in energy. They go to a lower point on our energy axis over here. The electrons like this. Okay, they don't really like it because they don't have feelings, but energetically, this is a favorable state. And therefore, forming these new molecular orbitals is energetically favorable, and this is why our reaction occurs and goes in the direction shown, because energetically, the products are favored over the starting materials. This is a way to think about this molecular orbitals and bonding in terms of energy. We can also look at the shape of orbitals. So we'll discuss this more, but these are A and B is meant to represent the two nuclei. As it turns out, we'll draw these orbitals in different shapes, and these shapes might look kind of like jelly beans or eggs, and sometimes we might shade them. But this kind of picture is meant to represent where do the electrons that are in this orbital, this molecular orbital, where do they reside? And so here is a kind of a picture of what the molecular orbital might look like and where the electrons reside. Notice for this particular orbital, for the most part, the electrons, if they occupy the shaded region, they're mostly between the two nuclei. And that's exactly where electrons want to be. They want to be exposed to as many positive centers as possible, as many nuclei center. And when they're between two nuclei, they tend to be very low in energy. And in fact, this picture is roughly what this molecular orbital might look like. So these are two ways to talk about orbitals. So we can talk about their energy and we can talk about their shape.